Okay, welcome back to Mathematics Kika after school lessons. In the previous video, I've proven this theorem using method 1. Then today we'll be proving this theorem using method 2. It says angle between the tangent to the circle and the chord drawn from point of contact is equal to the angle subtended by the same chord in the alternate segment, right? Angle between the tangent to the circle and the chord drawn from point of contact is equal to the angle subtended by the same chord in the alternate segment. It means M angle NQ is equal to angle K. Then we're gonna prove the theorem which states M angle NQ is equal to angle K using method 2. Okay, let's prove our alternate segment theorem. Prove the theorem which states M angle NQ is equal to angle K. Then we first construct NO and MO, right? Then we construct a line M to O and M to O, right? Then you mark them O1, O2, and N1, N2. You have M1 and M2, right? Then in this circle and the triangle MON, we realize that ON and OM are radius and are equal, right? The radius, there's a line drawn from a center of a circle to the circumference, a line drawn from a center of a circle to the circumference. Then these lines are equal. We can conclude that angle N1 is equal to angle M1, right? Then angle N1 is equal to angle M1. Then the reason is equal, opposite sides equal opposite angles, right? Then equal opposite sides equal opposite angles. And again, we have a we have a radius. This radius is perpendicular to this tangent, right? This radius is perpendicular to this tangent, which means we have angle of 90 degrees here, angle of 90 degrees, because this tangent is perpendicular to this radius, right? We have the 10 radii theorem. Then we can conclude that angle N1 plus angle N2 equaling to 90 degrees. Angle N1 plus angle N2 equaling to 90 degrees. Then the reason is 10 radii. Tangent is perpendicular to a radius. Then let's make our N1 the substitute the formula. N1 is equaling to 90 degrees minus angle N2, right? That's angle N2. Then in triangle MON, okay, in triangle MON, right, we realize that angle M1 plus angle O1 plus angle N1 plus angle M1 equaling to 180 degrees. Angle O1 plus angle N1 plus angle M1 equaling to 180 degrees. Reason is sum of angles in triangles. Angle O1 plus angle N1 plus angle M1 is equaling to 180 degrees. Reason, sum of angles in a triangle, right? Sum of angles in a triangle. Then from here we know that angle N1 is equal to angle M1. Then we can, when we see M1, we can substitute what? We can substitute N1, because M1 is equal to N1. When we see M1, we can substitute N1. It means angle N1 plus angle N1 plus angle N1. Where we see M1, we substitute what? We substitute angle N1. It means O1 is equal to 180 degrees. Then these two, when you add them, you get 2 angle N1. It's minus 2 angle N1, right? And then we realize that our angle N1 is equal to 90 degrees minus angle N2, right? Where we see angle N1, we can substitute what? We can substitute negative into 90 degrees minus angle N2, right? Where we see angle N1, because angle N1 is equal to this. Then where we see angle N1, we substitute this, right? Then is 90 degrees minus angle N2. Angle O1 is equal to 180 degrees minus negative 2 times 90 degrees is how much? Is 180 degrees. Negative 2 times negative angle N2 is plus 2 angle N2. Then angle O1 is equal to this one will cancel this one. Then we're left with 2 angle N2, right? Then go this side. We realize that angle O1 is 2 times angle K, right? Angle O1 is 2 times angle K. Angle at the center is twice the angle at the circumference, right? Then we can therefore write O1 is equal to 2 angle K. Then the reason is angle at the center. So our reason, because this angle is twice this one. Another theorem. Then know that O1 is equal to 2 angle N2 and O1 is equal to 2 angle K. Therefore, we can conclude that 2 angle N2 is equal to 2 angle K. Then we divide by 2, Then angle N2 is equal to angle K, right? And N2 is equal to angle. This one will cancel this one. This one will cancel this one. Cancel, they will cancel, right? Then realize that M angle NQ is the same as angle N2. Angle N2 is equal to the same as M angle NQ, right? Then M angle NQ is the same as angle N2 is equal to angle K. Therefore is proven. Then the theorem is proven. M angle NQ is equal to angle K. Then our statement, we are required to prove, in the RTP, we are required to prove that M angle NQ is equal to angle K. Then we are required to prove this. Then now is proven, right? From here, M angle NQ is equal to angle K. Then it's proven. Thank you.